In my role, I have the privilege of working with organizations across industries, helping them build digital twins that drive measurable outcomes. A couple months ago, I was running a workshop at a water treatment plant, the kind of facility that quietly keeps our organizations running. I learned that in order to make a single decision, like diagnosing a pump failure, operators had to pull data from static drawings, sensor feeds, work order histories, combined with knowledge only experienced operators carry. Unfortunately, that data lives in different places, owned by different teams, in different formats. And this is not unique to facilities. Step back to city scale, planners working across departments and data sources to decide whether a project should be permitted. And even emergency response, responders are making evacuation decisions in seconds, leveraging information from dispatch, field reports, and live conditions that keep changing. Different scales, different stakes, same core challenge. Fragmented data leads to disconnected decisions. This is where digital twins come in. A digital twin is not another system. It's how the system you already have work together to support decisions. It connects the data you rely on, operational, business, engineering, IoT, and geospatial, so you understand what has happened, what's happening, and what could happen. And it connects the people who depend on that shared understanding. Operators, planners, responders, so they can act together. Now, how do we make it real? It's through geography. Every system we just talked about has one thing in common: location. That's what makes geography foundational for digital twins and what grounds them in the real world. Geography provides the common reference that lets the real-world activity update the digital representation, and enables the digital insights to guide action in the real world. Let me show you what this could look like. A geospatial digital twin has 3 attributes. First, it integrates multiple data sources into a connected environment, creating a digital representation of the real world that stays current. Second, digital twins are time-enabled. They allow organizations to explore the past, monitor the present, and simulate future scenarios. Third, it's outcome-driven, tailored to specific use case. What you see are multiple outcome-driven twins supporting decisions in environmental analysis, urban planning, and facility management. And these are not just reserved for select organizations. In fact, as you've seen this morning, and will continue to see throughout the week, many of you are already building towards this integrated, time-enabled, outcome-driven digital twins. So to everyone in this room, you, as GIS professionals, are already laying the foundation. You are representing the real world through GIS, your assets, your cities, your networks, your environments. You might not be calling it a digital twin, but that work is already happening. So what could take you further? ArcGIS advances your digital twin journey from a strong spatial data foundation to reality mapping, real-time monitoring, spatial analysis, and applied intelligence, many of which were covered earlier this morning. And these are not features you build once. They are building blocks, each one adding to the foundation you've built. But before you put them together, ask yourself, what outcome is this twin driving? Because digital twins are not just built to impress, they're built to deliver value. That's what we call outcome-driven digital twins. Rather than building one massive, all-encompassing twin, these are purpose-built for domain-specific workflows and decisions. What's critical is that they are all fed by a connected data environment, integrated with your enterprise GIS and other systems of record. That's what enables connected decision-making, across teams and across your entire organization. Here are 3 examples: a facility operations twin, a planning twin, and emergency management twin. 3 domains, 3 outcomes, but the same promise: better decisions through connected systems and shared understanding. Another thing they have in common, all of them leverage 3D GIS, because 3D lets us see the world as it is. And that's how teams build a shared understanding across operators, planners, responders, and all other decision makers. With that, I'll hand over to my colleague who will show us the new 3D capabilities across ArcGIS built to support outcome-driven digital twins. Please welcome Madeline Shoren.
Thank you, Christine. This is a digital twin of Vancouver, Canada. Many of you are already building digital twins using GIS, and a digital twin is more than a 3D model. It's a living representation of the world around us. What makes it powerful is the information behind it. Beneath the schematic view are thousands of real-world assets. Here, property ownership is symbolized by tax assessment value, with many of the highest value properties concentrated along the waterfront. Digital twins also include infrastructure that's normally hidden from view, like wastewater, stormwater, and freshwater systems. And digital twins are dynamic, reflecting changing conditions throughout the day. As dusk settles over Vancouver, another layer of the city reveals itself as the streetlights turn on. So how do you start building a digital twin? For many organizations, it begins with a base map. And across ArcGIS, 3D base maps provide a rich foundation with trees, buildings, and place labels. They're detailed, authoritative, and ready to use. The topographic 3D base map provides a schematic view of Vancouver. And when a photorealistic view is needed, ArcGIS now supports the Google 3D base map, which reveals details in its imagery, like the cruise ships docked at Canada Place and the green roof of the convention center. With a 3D foundation established, the digital twin can evolve to reflect real-world conditions. For example, here in one of Vancouver's parks, recent construction isn't yet reflected in the base map. But using drone-captured reality data, in this case from our partner Spexy, we can mask out a portion of the underlying base map and seamlessly update it with a Gaussian splat. Gaussian splats are the newest 3D layer type in ArcGIS. They're highly realistic, shareable across the platform, and capable of representing real-world conditions with high fidelity. Notice the level of detail in the roller coaster tracks and support structures. By blending authoritative base map content with reality capture data, the digital twin mirrors what's actually happening on the ground. And operational assets, like lighting features, add another layer of context. As the park transitions to evening, these features are illuminated directly in the scene using the new glow effect, and our digital twin comes to life. Let's take a look at how this digital twin can be configured for an operational scenario in the heart of Vancouver. We'll start by uploading a BIM model of BC Place Stadium. 3D models with spatial information can now be uploaded directly in the web scene. And once it's been uploaded, we can add the model of the stadium along with emergency assets like fire extinguishers and emergency phones. And although these features would literally be hidden behind the walls of the stadium, new visibility options in the scene viewer ensure that they always remain visible, which is a requirement for these emergency assets. And all of this information can then be configured into a purpose-built application. Recently, Vancouver Fire Rescue Services and Vancouver's Technical Services Division evaluated a prototype digital twin of BC Place for use during a major international sporting event. This application was built using the ArcGIS Maps SDK for JavaScript and tailors the digital twin to the needs of the first responders. It includes facility information like 3D-enabled floor plans and fire assets, alongside interactive 3D tools like Viewshed Analysis. And this is where digital twins become transformative, where you can build the right twin for the right scenario, in this case to support situational awareness. And the same 3D baseline can be integrated into external systems to evaluate potential outcomes. For example, uCrowds, a crowd simulation company, used foundational data from the digital twin to model activity near a fictional festival near the stadium. As attendees leave both the festival and the stadium, congestion areas emerge in red. And watch what happens when we introduce a barrier to the scene. The simulation updates and the traffic patterns adapt, and we're able to evaluate different scenarios without making or before we make changes in the real world. The power of a digital twin lies in its ability to bring together authoritative data with real-world context, helping us understand today while exploring tomorrow. And these are just a few examples of what's possible with a digital twin. Before we wrap up, let's have a little bit more fun. As dusk settles over Vancouver, dense fog rolls in across the city, and the skyline fades into the background as our streetlights continue to shine through. And one place in particular is impossible to miss. Our amusement park is still glowing through the fog. Thank you.